Okay, well, thanks for coming along. This is a bit of a dry title. I'm hoping the topic won't be dry, so I'm actually impressed to have got people to turn up. Either that or you're here for a nice nap. Either way, I'll try and keep the noise down. But thanks so much for coming along. My name's Sam Newman. I am an independent consultant now. I have a company called Sam Newman and Associates because I'm egocentric and therefore like naming things after myself. So anyway, if you want to know more about what I do, you can come talk to me later. I also wrote a book a couple of years ago called Building Microservices, which you may or may not have read. If you like learning about microservices, it might be the book for you. This topic is not about microservices. This is actually really in some ways about my first sort of love and passion, really, which is helping people get software into production quickly. That was my focus for many, many years. And actually that led me to look into microservice architectures as a way of making it easier to create loosely coupled architectures being something which are much easier to ship into production more quickly. I want to take you back in time, actually, to give you a bit of a history lesson, really, to explain my journey into the world of continuous integration and continuous delivery. And what we're going to be doing in this talk is recapping a number of sort of central tenets around CI and CD, looking into things like feature branching and feature toggles, and re-examining them in the context of the emergence of Git and GitHub and new types of development practices that we now have, and really trying to think, okay, does the advice that we gave back in 2005 around these sorts of things, does it really stack up in the new world based on what we know now and based on how we develop software now? This story does start in, at least for me, in 2004, and I just started as a pimply-faced youth at ThoughtWorks. And they said, okay, so it was my first day at work, and they said, okay, you're going to go to this platform at Euston Station, and between the fourth and fifth pillar, there'll be some people standing around, and they'll look like you're going to be working with them. And you'll just have to work it out based on what they look like. And I think it spoke volumes about the lack of diversity in the team at the time, which was, it was very easy to walk up to that platform and see exactly who it was I was going to be working with. But nonetheless, so we would get on the platform and we'd trundle all the way up to where the client site was, in a place called Hemel Hempstead. If you've been to Hemel Hempstead, you'll know very little about it, really, because it's quite an anonymous place. So we get on the train and trundle all the way up, and we'd have dreams on the way to Hemel about maybe if we just stayed on a few more stops, we could just get off at Bletchley Park and no one would notice. Just wander in, go and have a look at some Enigma machines and some Turing Broms. We never did it, though, because we were dedicated professionals, and also because, often the train stopped at Hemel Hempstead. Anyway, I arrived at this project. It was a very large project that ThoughtWorks at the time was running, primarily doing the development in the United Kingdom, but also with support from people in Canada and India as well. And it was a project for one of Europe's largest retailers, and it was sort of a form of a rescue project in a way, which was that this company had engaged another supplier to create a brand new electronic point-of-sale system, and that electronic point-of-sale system was late. And so they said, oh, it's very, very late. They got rid of one supplier and said, come in and fix it. And so we turned up, and it was, I think it was supposed to be an 18-month project originally when they started it, and they were 18 months in, and they were still 18 months away from delivering. And I think everyone can do the maths and work out that's not going in the right direction. So it was sort of come in, it was all hands to the pump, and then we've got to fix stuff, we've got to make stuff happen. And this had been going on for probably about a year or two, I think, before I got there. And so I arrived at an interesting juncture in the life cycle of this project. This retailer had multiple different stores, different branches, different types of chains, had different brands underneath the overall banner. And so they'd been slowly rolling out this new point-of-sale system to different stores and effectively cutting new releases to represent each store rollout. A new set of features. These releases were almost like a milestone, so a collection of things. And so we had most of this development had been done up to this point was being done on the R3 branch of code. And so this was the kind of the new cutting edge features that we were working on. This was like a mix of a monolithic server backend and a swing-based front end, which is what the electronic point-of-sale systems are running. In fact, they still run the same point-of-sale systems to this day. And so the bulk of the organization at this point, the bulk of the delivery organization, was working and making changes on this sort of R3 branch of code, and this was the current release. And they're actually putting out multiple deployments from that branch. It wasn't like, they was only going to do one release. They were actually releasing fairly frequently from that main branch of code. Now, as I mentioned, this project initially had started off in a bit of a hurry, as in we needed to get something out. And so, as is always the case, when you have to make compromises between doing things the right way and actually having software that works and being used in production, you sometimes have to make a few compromises, and compromises had indeed been made. And around the time of the R3 branch of code, when those releases were getting out, the team were getting a bit of breathing space. To give you an idea, at this point, you had about 60 developers working across multiple teams on this project. And things were fairly stable, and things were getting out nicely. The core feature set was being used quite widely now, and we thought, okay, well, this is a great opportunity to sort of clean up a few things that we'd done that we knew were shortcuts. But also we'd learnt a lot about how to build the system well, and we wanted to make some architectural changes. Also, there was things like, we had 2 or 3 different ways of achieving a certain goal, like persistence, for example, was being done in multiple different ways, and it was thought, actually, we could unify that as well. So what happened was that the decision was made to actually have a small team go and start looking at making these targeted changes. But some of these changes were going to be quite disruptive, and so they did what we would traditionally do at this stage of this is part of our software development life cycle, which is we created a branch. And so that small team went off and started making these refactorings and these changes on a separate branch of code, which is called R4. And the idea was, at a certain time when they were ready, R4 would become the brand new release branch. It would be the version of the code that starts running in all these stores. And so changes were still being made by the bulk of the team, which stayed working on R3 and now are delivering customer-facing features out to production. The R4 branch of code was a refactoring branch where new abstractions were being created, new ways of working. It was a lovely, lovely, lovely clean code base at this point because they'd been doing so much refactoring. And then they said, well, OK, we think we're in a good place now. We think this can now become the brand new release branch. This should now be promoted to being what we release our code from. And, of course, at this point, we had to do what we always have to do at this point, which is now merge all the features that have been worked on in R3 over onto the brand new R4 release branch. And, of course, that went really, really well, as you can imagine. There were definitely absolutely no problems whatsoever, and it was a completely painless process, and nobody died. Actually, no one did die. But at some days there, it was pretty bad. So it took a while to get the code to compile, a few days, I think it was. But then you had this whole process of just like the textual merging of like, well, they've renamed things and things have moved around, and that took a long time carrying out that initial merge. And then we started realizing that even though we thought we'd done the merges, that we'd introduced a whole load of bugs and defects. We'd introduced regressions. Features that we thought had been cleanly merged over had actually been sort of regressed and hadn't actually been properly merged at all. They weren't working properly. We'd introduced brand new bugs because of just clashes in functionality. And so it was decided to create a team to target fixes in this area. Hence the creation of the R3, R4 merge bug fix team. Doesn't it just get your pulse racing? When you arrive on site on your first day and you've learned all this stuff about this amazing company, these great people that work there, and how much awesome technology there, and it's Martin Fowler's company, and he does loads of great stuff, and then you turn up and they say, hi, Sam, you're going to be working in the R3, R4 merge bug fix team. And it did exactly what it said in the tin. I mean, my initial reaction was obvious. Yeah, well, thank you. I wasn't at all annoyed. I learned a lot, to be fair. Hence, kind of almost it kick-started at that next phase of my career, because I got to really live through the experiences of what not to do and deal with the aftermath of that. I will say that there was a bit of a postscript. Many years later, I lived in London, and many years later, I was woken up in the dead of night. My bed was shaking, and it turned out there'd been an explosion at an oil refinery next to the site where we'd been working in Hemel Hempstead. Luckily, no one died. No one was even injured, amazingly. But I do sort of like to feel that this was sort of some sort of deferred explosion as a result of that merge of code. It would have been much more poetic if it happened on the day we did the merge. So there's a lot of things that came out of that experience, not just for me, but for many others. And the seeds of the continuous delivery movement started on that project. Dave Farley, who was the author, one of the authors of the continuous delivery book, in fact, was the architect on that project. And of course, at this point, many people will be saying, but Sam, weren't you doing continuous integration? Weren't you actually continually integrating your code and validating that code works together? That's how we reduce merge pain. So I'll just do a brief recap of what continuous integration is. I think Actually, hands up here, who is doing continuous integration? Put your hands up high. Okay, most people claim to be doing continuous integration. So I'm going to recap it, though, just to make sure we're on the same page. It's really a very simple process. And it's a mechanism by which you make sure that the code that you've committed works with the code that's already there. You integrate that code together, you validate it. So you work on your laptop, on your desktop machine. We were working on laptops back then. It was a rather embarrassing moment when the retailers' offices were burgled and everybody's laptops were stolen apart from our laptops. And even burglars decided not to take Toshiba Tecra laptops. It was sort of the size of small planets that you'd carry around. Anyway, so we'd be working away on these sort of Titanic-sized laptops that were steam-powered, and you check your code in, and these days it was not Git. It was not even Subversion back then. It was something a lot worse that I won't name because I think the vendor still exists and they might get angry. So you check the code in to the source code repository, and then some kind of continuous integration tool detects that change. So it could be a polling change or it could be a post-commit trigger, and says, OK, well, I'm going to kick off an integration process. And I'm going to tell you whether or not your integration has worked. So starting off with the basic stuff like, does it compile? People do think that's a bit silly. Does it compile? Believe it or not, I spent a good 5 years helping roll out continuous integration to many companies across Europe, and that was often a huge improvement in their current state of affairs, making sure that the code actually all compiled together. Anyway, we've got better. Now, of course, we talk about different test suites, and those of you at the previous talk would have learned how far testing has come since then. So, this is the process of continuous integration. There are some rules about what continuous integration is, and this is where things get interesting and people get quite cross, because they say, that's not continuous integration, and actually, yes, this is. This is what continuous integration is all about, right? You check in a change, and you get it validated. And that's very straightforward. Somebody else checks in some code, and they get their change validated. Validation of the integration is key. Compilation, running some tests. You have to have a suite that validates your integration, otherwise you're not doing continuous integration. When the build breaks, when you check in a change that breaks your build, it should be the #1 priority of the team to fix that build. You want to keep your builds green. Normally that means that the guilty party who checked in the change has to go and fix it. Right. That's normally the rule, which also leads to patterns of behavior like nobody checks in after 4 o'clock on a Friday because everybody wants to go home. It's a brave soul indeed who decides to check in at 4 o'clock on a Friday. So when the build breaks, it's your job to fix it. And normally what you would do is stop the line and stop anybody else checking in so that change can be made freely. The other thing, and this is where things get kind of interesting, this is the rule. The other rule of continuous integration that most people forget is that you check in daily. If you take a long time between integrations and you decide, oh, I've been making these changes locally for days and days and weeks, and now I suddenly decide to check it in, you have a huge merge problem, you're likely going to break the build and annoy everybody. Continuous integration states extremely clearly that you check in daily. Now, I'm not saying that if you don't check in daily, you're a bad person, or that it doesn't work for you, or isn't successful. That's fine. It may well work perfectly well for you. It's not continuous integration. Just being very clear. So when we're talking about what continuous integration is, this is what it is, right? Integrating your changes daily and validating that they work. So we want to check in frequently because we reduce the merge pain, we reduce the chances of conflict, we reduce the chances of problems, and we break that merge pain up. And so, of course, when we talk about the R3, R4 merge bug fix team, the question I had was, well, weren't we checking in together? Weren't we integrating our changes and making sure they worked? And the answer was, we were, kinda. We were doing what was quite common, which was actually we were running CI builds on branches of code. So we had the bulk of the organization who were working on the R3 code, and they had a build on the R3 branch. And they were checking in their changes, and those changes were being validated, and they were getting feedback that, yes, their changes worked. Likewise, the R4 team were checking in their changes on a branch of code, validating that, yes, they did work. The issue, of course, is this integration was localized to those branches of code. The code wasn't actually being integrated together. What that meant was that when we decided to move the functionality from the R3 branch over to the R4 branch to make that now the live release branch, we had a giant pain. The reason, ultimately, that this merging wasn't happening more frequently was because that not only were the cost of branches quite high, and so you had long-lived branches, but also the difficulty and complexity of merges was quite high. And we fell into this nasty pattern, which is, oh, branches are nasty. Merging is really difficult. Let's not merge a lot. We might as well bundle up all the pain and defer it, because then future Sam can deal with it. And future Sam did indeed have to deal with it over many, many, many months. So this idea of integrating once a day, which is very strong in continuous integration, wasn't really what we were doing. We were integrating locally into those local branches. And so we had this problem. Now, the reason, of course, that we weren't just making these changes on the R4 code base, these sort of refactoring straight onto the release branch of code, is because these changes often required multiple separate steps. You were checking in work that was sort of half finished. So what we don't want to do, so I'm working on a piece of code, a piece of functionality it's going to take me several days to complete. I don't want to just leave it lying around on my laptop, which is the option that certainly we used to live by, where I'm just going to wait to check my code in. Now, of course, if I wait to check my code in, I'm deferring that integration effort. I'm also running the risk that something might happen to my laptop, like it getting stolen, and lose my source code. So we want to put it somewhere safe. So I can't just wait to check in my half-finished refactoring, my introduction of a brand new piece of functionality that's only half ready to go live to my customers. And so really waiting to check something in doesn't really make sense. So then we look at the other option, and effectively what had happened with R4, just in a big way, which is what we're going to do instead is we're going to make a branch of code. We're going to make our changes locally on that branch of code, making those changes safely because they're not actually going to be released until we've completed that process. And then once we've completed that process, we then merge that code back into the release branch or promote the branch we're working on to being the release branch, which is the technique used at the retailer. This is a classic release branch mentality. So I've got maybe trunk or whatever my release branch is going to be called. It might be called master, depending on your version control tool of choice. And you start working on a feature. And so what you do is you branch the code, you fork the code, and you start making your changes locally, probably in a branch named after the feature. So you do this work for a few days, and one of your colleagues starts doing the same thing. They make their fork of the code. They start making their changes locally. And when they're finished, you merge your features back into trunk. And at this point, it's probably OK, right? Because I've been making my changes. Not much has shifted since I took my feature branch change, and I checked it in. And I've checked in a few new little refactorings. I've cleaned up some code. I've renamed a few things, make it easier to understand. And then my colleague comes to check their change in and suddenly realized, oh, look, a whole load of stuff has changed in trunk. I've now got to actually check all of my stuff in, and it's a much more painful process because I'm now having to deal with that large delta of change that comes from the other feature branch being merged in. This often leads to nice, interesting social patterns of behavior, like you've got a nasty check-in that you want to push that is going to make it really awkward for other people to merge in. But you want to get your change in first so you have the easier time of it. And so you sort of distract people. You say, oh, look over there. And you quickly check in the code. I do remember on one occasion actually distracting one of my colleagues and trying to enter their password 3 times on their lock screen. Because when you did that, it actually locked the laptop because they thought it was being attacked by some malicious party. And you had to go and contact the sysadmins to get your machine unlocked. And so me and my pair did that and sort of just locked the machine for them. They couldn't get back in, or we could get our change in, right? This is just all to make our life. I mean, this is not great stuff, but it kind of allowed us to go to the pub. They weren't so happy about it. Now, of course, you can actually, again, make these processes a bit easier. I mean, one of the things that you can do, for example, is you can run CI. You can use tools like Go, for example, make it very easy for you to run a CI build on your branches. And you can actually configure these tools now that when they detect a branch, they'll automatically run the builds on them. So at least locally for your feature branch, you're getting validation that your changes are working. You can also, of course, pull changes from your trunk or master onto your feature branch to also make things a bit easier for that final merge. You've picked up any other changes that have been made, and you can do a bit of a merge effort every day. The issue, of course, is it still doesn't avoid the problem like this. Even if I'm rebasing from master, the other feature branch, if that gets checked in ahead of me, there's going to be this large change sitting there waiting for me once I do that final pull. Ultimately, in this process, we are deferring integration. That's what we're doing. We're doing local integration on our own branches, but we are deferring integrating all of those things together. Now, ultimately, I think what my lessons learned from the retailer back in 2004 was that a lot of the pain that comes down to these merge activities and these integration activities come down to the size of the change and how long it's been since you last did your merge. There's some sort of function in there, I think, that I'm working on, which is like, you almost need a painometer for your branch that's telling you, oh, no, this is getting pretty, oh, no, there's been a lot of changes right now. You're approaching danger zone territory right now. You better get this stuff merged back in, otherwise you're going to be in a lot of trouble. So that it's not just the size of the change, not just the delta between what you've got and what is on the trunk you're going to merge with. It's also been how long since you last did a merge as well, just because it's quite hard to understand the changes that have been made. You've lost context a lot of the time to understand what the right thing is to do. Because ultimately, the longer you go between merges, it's less likely your changes are going to be purely textual in nature. You're actually looking at semantic changes in functionality and in the structure of your code base that you really need to understand and grok to be able to carry out an adequate merge. And this is the other problem, really, that comes with branches, especially branches that are longer lived. Refactorings are very hard to merge. So some source code tools like Git can do an OK job of picking up a very simple... Wow. I think my beard's too big. Can people still hear at the back? OK. Am I coming out over the mic, the PA? OK, all right. So merging and managing refactorings on branches can be quite challenging. The reason is, if I do something simple like a rename, I just change the name of a file, change the name of a class, most modern source control tools can do a fairly good job of saying, this is probably the same thing, and I can probably handle that merge for you. But think of the other kinds of refactorings you might do, like removing duplication, creating brand new abstractions, moving code into new modules and new packages. The more aggressive your refactoring are, the harder it's going to be to merge. What this leads to is organizations that practice branches that live for long periods of time tend to not do much refactoring, because refactoring is really hard to merge. And so you don't do the refactoring on the feature branches because it's just going to make your life more difficult when you come to do the merge. And so the longer the branches live on your code base, you'll find managing the refactorings are less likely to happen because of the merge pain. The other option you've got, so rather than just avoiding checking in, and rather than maybe making feature branches, is just to check in your half-baked changes anyway. Right? This is it. We're just going to check it in. We're not going to do a feature branch. The code's not finished yet, but we're checking it in anyway, and it's all going to be fine, which, of course, makes absolutely no sense, because by definition, your changes are half-baked, and they're not finished yet, and they're not fit for purpose. So how can we just check them into the same branch of code or the same trunk without causing problems in our release cycle? This is actually effectively a technique called trunk-based development. And the mantra behind trunk-based development is that everybody checks into trunk. This is one of the main ideas from continuous delivery. So rather than putting in branches of code, we all check into the same trunk. So it's a very simple approach in a way. I'm checking changes in every day, maybe like once a day at least is what I'm looking for, like with continuous integration. And the idea is that you're breaking up your merge pain. You're making lots of very, very small, tiny merges where needed when you're putting changes from other people. And you're breaking up that pain and integrating your code very, very often into the same trunk. So you're integrating often. You're getting very, very fast feedback on the quality of your integration. You're not deferring that integration. And that merge pain is significantly reduced. I often think, I don't think a big merge is a sum of a lot of little merges. I think, it's actually worse than that. I think it's the multiplication of a lot of little merges. But of course, this doesn't really help explain what we do about half-finished features. I'm halfway through making a change in some piece of functionality, and I can't clearly release that out to my customers. So trunk-based development goes hand in hand with what are called feature toggles, or sometimes called feature flags. What we do with feature toggles or feature flags, and I'll call them feature toggles for the rest of this talk, is that we hide half-finished functionality behind these toggles. And so we check in the code. It's integrated in with branch, but effectively use a toggle to mean it's not in the live code path. So it's a very simplistic example. I've got a web page here, and I'm working on some lovely brand new widget. So I'm working, in fact, on a thing called the super widget. And what I do is I have a flag, in this example, in the configuration file. And once my widget is ready to be released, I change the value in the configuration file, and my widget appears. Having the ability to toggle these things off and on means that what you can do in, say, your test environment is turn your toggles on and actually test the partially implemented functionality. The code itself is actually live inside your code base. So you can still run subcutaneous tests against that functionality, but it's not exposed to the users. There are lots of other ways of specifying toggles. You can do it with a configuration flag like this. You can do it with a flag on the command line. This is how Google do their flag system. And you can also even use sort of centralized systems to manage the value of your flags. And that might allow you to toggle those values off and on. So people have been using things like Zookeeper and Console to actually store the value of your flags, allowing your applications to dynamically turn things off and on in production. So that's kind of nice when you've got a public-facing change, and it's a brand new piece of functionality. It's actually quite easy to get a sense of how you hide a piece of brand new functionality that's half implemented. A new widget on a page is actually a really easy thing to get your head around. Likewise, a new page on your website, it's just not something you wire into your main information architecture. It's just not visible to people. But what if it's actually a change in an existing piece of functionality? So there's some functionality that's already there, you need a brand new implementation of it that changes it quite fundamentally, but you can't get rid of the old code right now because it's actually still being used. It's still actively being used. I mentioned a tool called GoCD earlier, and actually I've got a great example of how you can make this work from the deep, dark history of Go. So Go is a sort of deployable, a locally deployed CI and CD server. It's been around for many years. It started off as a product called Cruise very early on, and it's changed a lot, as you'd expect any product to change over many years. About 6 years ago, they made the decision to migrate how they were handling persistence, migrate it from a tool called iBatis over to using Hibernate. The reason for this change was that iBatis requires sort of handcrafted SQL queries, and that was becoming hard to maintain. And they wanted to replace their persistence system with a brand new persistence system, which is Hibernate, to allow them to talk different databases and also support different databases of their clients. And so in the existing system right now, the iBatis persistence layer was sort of very deeply integrated in the rest of the product. Because lots of things need to put stuff into a database and get it back out again. And so we need to sort of start working and incrementally changing over this persistence layer. The issue, of course, though, is that this is a product that people are using. It's not a SaaS-based product, but nonetheless, Go is shipping features, brand new versions of Go to their customers every 2 weeks. And in fact, I think now it's every day. So you go to the website, and you could download a new build every single 2 weeks. This change was not going to take 2 weeks. This change was going to take probably several months. So you don't want to put stuff on a branch for a month. You want to be checking this change in incrementally. So how do you make that work while you're still trying to cut new builds of software that also have to work? The pattern used here is something called branch by abstraction. And the idea is that rather than saying, OK, I want to check in a different version of my code on a branch and then merge that in, I'm actually going to effectively check in a new implementation of some piece of code into trunk and hide it using an abstraction and toggle between the two different implementations. So they started creating effectively the skeleton of what the new Hibernate persistence was going to be, and then created an abstraction layer. And so you had to move all of those calls from the existing direct calls into the iBatis persistence layer, and now they're talking to the abstraction layer. That abstraction layer then routes all the traffic through to your existing iBatis layer. And what you could do is you could configure that abstraction with a configuration value and flick that flag off and on to switch between persisting your information in iBatis to switching it over to Hibernate. Now, obviously, this Hibernate stuff didn't work for weeks. They were implementing effectively method by method, going along, implementing those new methods to use this new persistence layer. And so they had the flag. You could flick that on, but it was a deep hidden flag that only was being used by the development team and for the test team. And so as they migrated certain slices of functionality over to using the new persistence layer, what they could do is flick that flag on in a test environment, run tests against it, and make sure that that stream of functionality works the new persistence layer. But for the public, that flag was switched off. Once the migration had occurred, and this was done over many, many months, because what they were doing was a sensible thing, is they're making an architectural change like this while still shipping features, and they were like chipping away at it. Every new story they did, they'd chip a little bit further away. And I like this idea, rather than doing big bang rewrites, you're just making small incremental changes to your software. And so when they were ready, and they migrated it over, they could get rid of the old code, and also get rid of the flag as well. So that's the key thing. One of the big mistakes people use with feature toggles and feature flags is that they keep them lying around for a long period of time. When you don't need the flag anymore, get rid of them. So this is a nice way, it's a nice alternative to feature branching. Rather than having to branch out new alternative implementations of existing functionality and then merge them back in when you're done, you effectively create a new abstraction that allows you to have a new implementation of that functionality side by side, and when you're ready, switch it over. So that's branch by abstraction pattern means you sidestep the need for feature branching. So as I mentioned, with flags, there are some rules. Use it in as few places as possible. Normally 1 is a good number of places to use a flag in. And 2 is getting iffy for me. The more places you use a flag, the more complicated it's going to be for you to reason about what the behavior of that flag is going to be. And do remove those flags once you're done. I did work with one client who had over 300 flags that were different in their production environment and their QA environment. And they had never removed those flags. And so it became kind of impossible to understand which flags were actually in active usage. It was also impossible to understand the differences in behavior between those two versions of code. With monolithic systems, you may have a few more flags than you'd like. With a microservice-based architecture, you'll probably end up with fewer flags because often you can control release of functionality to your customers just by not shipping a service in the first place. It also keeps the number of flags per service down to sort of a minimum size. But with a more distributed architecture like that, you're more likely going to need some kind of system to help you manage those flags. We'll talk about that in a moment. There are some nice benefits to creating these abstractions that allow for functionality to be toggled off and on. The first is that this same sort of technical capability can get reused for things like A/B testing. So with A/B testing, what you're normally doing is you're diverting a certain part of your traffic to one version of functionality and a different set of your traffic to a different version of functionality. This could allow you to test different treatments, for example. So this would actually be one way of potentially seeing if the new implementation of some piece of functionality was actually better for your customers than previously. And then if it was, then you could effectively remove that flag and turn it on for everybody. And also, with a bit more work on top, you could also use this sort of mechanism for something like canary releasing, although that tends to apply a bit more work. But ultimately, the abstraction points around that can help for things like canary releases. If you want to know more about the ideas behind trunk-based development and branch by abstraction and feature toggles, an old colleague of mine, Paul Hammond, has started putting together a whole lot of interesting resources over at trunkbaseddevelopment.com. And so if you want to take a look at that, that might give you a few nice pointers. Now, emerging from the ruins of the retailer project, which actually went very, very well, I must say. The client was very happy. The software got shipped. No one got fired. No one died. But a lot of lessons were learned, and many of those lessons ended up in the continuous delivery book, which Dave and Jez started working on in, I think, 2007, 2008, but it was finally published actually in 2011. And it talked in that book a lot about reducing the use of branches, limiting long-lived branches because of this integration pain, and promoted this idea of trunk-based development as an alternative to feature branching, really but motivated by the idea of continually integrating code to reduce merge pain and actually also be able to ship functionality more quickly to your customers. The other ideas that came out from this book in 2011 were things like treating every check-in as a release candidate, which in many ways is the sort of main idea in the continuous delivery book. Rather than this idea that I'm going to check in some code and then later on I'm going to validate whether or not that code's good enough and then maybe we'll do some more cherry picks to make it work and then we'll ship it. Now it's sort of shifting things much more onto the hands of the developers to say, no, you don't get to abdicate responsibility. You have to be confident that every check-in you make could be released into a production environment. And so there's a bunch of stuff in the book to explain how you do that. Another idea that comes out in this book is about reducing the size of changes and increasing the frequency of deployment. I mean, this idea and the reasons behind this idea are put out quite well by John Allsport. He basically did this lovely presentation about metrics in the ops space, and then explains really nicely in 2 slides why continuous delivery is such a good idea. The idea goes like this. If you take a long time between releases of software, you have more changes build up. And so the delta between one release and another is larger, and therefore you increase the risk that you're going to introduce a problem. There's more chance that you're going to screw something up if you've made a lot more changes. And so if you do check them in and you have made a mistake and you've broken something, Because of the large delta, you've also got a lot of functionality to look at to understand what it is you've broken. And any ability to fix that release is made more difficult because working out what's broken is harder. So working out what you can patch or roll back is more complicated. So the releases themselves are more fraught. You're more likely to break something. If you break something, it's going to be harder to fix and harder to roll back. And what happens when we have these long release cycles is we do things like this. We say, well, this release is quite risky, and the last release we didn't work out so well. So what we're going to do this time around is we're going to be extra specially careful. We're going to be really take our time over this next release and get it right. We're going to put a few more procedures in place, a lot more sign-offs to make sure we can't possibly make a mistake. And what happens is the next release takes you even longer to get out the door because these new procedures you've put in place to eliminate the possibility you've made a mistake. And that release, of course, because it takes much longer, has even more changes in it. And when you release it, lo and behold, oh, look, it's broken as well, and there's a whole lot of problems with it. So what we're going to do, this time it's going to be different. We're definitely going to get it right this time. Let's put some more procedures in place. Let's put some more sign-offs in place, and it's going to be wonderful. And it's going to be absolutely fine. And, of course, this sort of vicious cycle continues. A lot of the work I do about sort of helping customers ship software more quickly into a production system comes down to looking through their release processes. And it's sort of like looking at organizational scar tissue. Right? So there's the procedures that are put in place because of something bad that happened about 10 years ago that no one can quite remember. And so I say, well, so there's this bit in the release process where you seem to like etch a pentagram in the floor with chalk and slaughter a chicken and say these words. I mean, is that really necessary? Well, it's what we've been doing for many years and it hasn't done us any wrong. And it's like, okay, great, all right. Breaking out of this cycle is really hard, but it's actually something you need to do. Because ultimately, if you ship software more quickly and more frequently to your customers, here's what happens. Each individual release is smaller in scope. Therefore, you are less likely to screw it up. And if their problem does occur, it's much easier for you to work out what it is you broke, and it's going to be much easier for you to roll that change back or roll it forward by fixing it. It also means you're shipping functionality to your customers more quickly, therefore getting feedback as to whether or not the features actually do what you want them to do. You also have a release process that you're using more frequently. Therefore, that release process is more likely to work because it's being used over and over again. And it's tried and tested. So this idea of decreasing the size and scope of each release, releasing functionality more quickly to your customers, is actually about reducing the risk of releases. It's actually about being safer. There is this sort of idea that comes that's spouted that you can either go fast and break stuff or go slow and steady and make not break stuff. And it's absolute rubbish. Those organizations that ship software really quickly do so only because they have really reliable, rigorous release processes that allow them to ship software in a safe fashion. Releasing more quickly actually can help you have a more robust release process. You can go fast and safe. And so this idea that you have to choose is absolute rubbish. So this other idea is integrate often, keep those batch changes small, keep those check-ins small, and ship your software frequently. All of these ideas coming out of the continuous delivery book. In many ways, what happened in that whole period of time was we took a lot of the practices that were coming out of enterprise delivery, that were coming out from the XB movement, lots of unit testing, automated testing practices, continuous integration, and bringing those. But those sort of practices had given us sort of higher quality, more certainty, more visibility into the quality of our software. But really, we weren't actually necessarily delivering our software more frequently to our customers, to our users. You'd ask people how often they released their software back in, say, 2006, and every 6 months was good, right? How many people here release their software every month or more frequently? Right. How many people here, they release their software once a week or more frequently? Right. If I'd asked that question 10 years ago, people would have thought I was talking crazy. What happened was these ideas came out that gave us visibility into the quality of our software, but we weren't quite fixing that last mile problem. And then you had all the .com people coming out, shipping software like Flickr were 15 times a day. And these ideas sort of came together and gave us what the continuous delivery movement was all about, really, which was saying, okay, let's bring together those practices about visibility of the quality of our software, marry that together with fast and frequent delivery, and overall, everything gets better. So while this whole thing was happening and we were automating build pipelines and measuring cycle time and helping people ship their software more quickly, this little thing called Git emerged. Git's actually been around, obviously, for quite a while, but we should probably understand a little bit, and a number of people think that Git shifts the equation in terms of how we develop software. We should, though, remember the history of why Git exists. So Git exists because there was a falling out around licensing for the distributed version control tool being used by Linus and the Linux kernel administrators. So Linus decides to write his own, and that's what Git is. It's a rewrite of it's an implementation of a distributed version control tool to suit Linus and how the Linux kernel is developed. And the main goal in creating Git was to allow Linus to merge a patch in less than 3 seconds. That was it. That was the goal. The whole architecture of Git is actually predicated on the requirements, primarily, of the Linux kernel. The Linux kernel is not one thing. It's not one deployable. You have the idea of the Linux project, but multiple different vendors build their own kernels. And there's lots of ideas. You're moving patches around. You're applying your own patches. And this is a fundamentally different sort of delivery process than most of us use. But most of us now use Git, which is a version control tool designed for a different way of working. There are some lovely things in Git, though. Right? Firstly, branches are significantly more lightweight. One of the problems with the retailer I mentioned at the beginning was that we couldn't afford to make lots of branches, and so we had that R4 branch that we were trying to do a lot of things on. We would have been much better off if we could have created more short-lived branches. The version control tool we were using, branches were very, very expensive. It's worth remembering with something like Subversion, for example, when you branch code, that's a copy of the code that's being stored. That's a lot of work, so branching is not something you did lightly. With Git, it's really simple, right? It's such a lightweight operation that the creation and management of branches is much easier to work with. You have other nice things, like you have a full copy of source history in your local laptop, which I always like when I'm developing on planes and in trains with poor connectivity. And also, we have significantly better merging of text, which has made merging code easier. Certainly much better in Git than it was in Subversion. The key thing to understand, of course, is that Git has got better at textual merging, identifying this thing is probably the same as this thing. This is probably a rename. This is probably a move. Oh, I can kind of work out that block where that goes. But it can't merge semantics. It can't understand the intent behind a change that was made by somebody else and apply that intent on your code. There are no operational transforms yet in our source control tools, like there are for our sort of document sharing tools. There are people working on things like this, people who are actually building whole IDEs and source control tools that actually implement the understanding of intent. These systems actually require you effectively to hook your refactoring tool into your source control tool. So you actually say, I've done a refactoring. You actually store the refactoring, not the output of the refactoring. And that makes it easier for you to apply those things on other pieces of code. I don't know anyone here that's using this stuff yet. Maybe in the future we'll have this, and this will make merging branches even easier because it will operate a lot more like actually collaborative editing documents does at the moment. So Git came out and was starting to be used by many people, and in a small community, really, initially, but it started to pick up, and a few people were kind of interested in it, but sort of like interested in it in an academic way. Oh, it's distributed version control tools. There'd been others around before, but this is a new one. Oh, let's give it a bit of a look. Oh, this is interesting. But most of us were still using normal, traditional, centralized source control tools. The thing that really made GitHub popular and changed the way we think about software development was GitHub. GitHub launched in 2008. It took them only a few short days after their release to expose something that changed how we think about open source software delivery and software delivery in general. So I think it was their third blog post after they launched. They exposed the pull request button. Now, Git has had a pull request functionality built into it from the very, very early days. GitHub implemented their own type of pull request mechanism on top, which is something that Linus is still angry about to this day. But he seems to be angry about an awful lot of stuff, so I can't keep a list. And this functionality drastically changed how easy it was for you to contribute to an open source project. Previously, if you wanted to make a change to an open source project, what you'd have to do is you would have to either become a committer, or you would have to get that code, check it out, make the change locally, test that change, and then generate a patch file. So thank you, Larry Wall, for the patch file format. You would then send that patch file probably via email to one of the people that had the commit rights to that source code repo and say, here's a change, can you make it? Can you make it for me? And so that committer would then have to merge your change in or just give you commit rights. Most of the time, you'd have to submit a few patches to a project before you would be allowed to actually be part of the core committer group. With the pull request model, you made it very easy just to create a branch of that code, make your changes locally. You send a pull request to the committers who can then merge your pull request in using Git itself, significantly lowering the barrier to entry to making changes. And project after project moved away from using centralized source control systems, moved away from source code hosting, like SourceForge, for example, over to GitHub primarily because of this. There's a bunch of really nice visualizations of source code, of sort of the history of source code from version control systems. And this is a little snippet of a visualization of the Ruby on Rails code base. And so this is a graphical representation of the people who committed to the project and the commits those people made. So we can see here a small number of developers. And around this point, they actually moved over to GitHub from SourceForge. And what you start seeing is a drastic uptick in the number of committers that were actually coming in and contributing functionality to the project. It wasn't just that the number of committers increased, it was also that the volume of changes that came in increased. This was hugely impactful for this project and really allowed it to kick into high gear. And this is an experience that was mirrored by project after project in moving over to the GitHub environment. And it was no surprise that sort of shortly after they launched, not many years after they launched, this was what, 2011, that GitHub actually outstripped both Google Code, which has now been shuttered, and SourceForge in terms of that number of commits it was handling and the number of projects it was handling. That's a pretty meteoric rise in just those 3 years. This is primarily down to the ability of a pull request, in my opinion. That's the real empowering thing about open source development. It makes it much easier for you to accept contributions from the outside world. You've drastically lowered the barrier to entry for making those changes. So this is fantastic. But of course, at this point, you're saying, but Sam, PRs use branches. And yes, they do. When you make a pull request, you are creating your changes on a branch, and you're asking for someone to pull that change in. And so the same challenges do occur. The larger the change you're making, the longer you've been working on that change, the bigger, effectively, the PR is going to be. But if you're a maintainer of a project and someone sends you a huge delta, a huge PR, it's going to take you a long time for you to review that change and make sure it's good enough to be checked in. So we want to keep our PR short, just like we want to keep our branches short. The key thing to understand, of course, as well, is that open source development isn't about a bunch of full-time people working 9 till 5 to create some end-to-end product. It's actually about people who have an hour here and an hour there and 2 or 3 hours on the weekend to make a change to an open source project. They're mostly doing it out of the goodness of their heart. You have also a mix of trusted and untrusted committers. Normally, the trusted committers can commit directly in without needing to do PRs. So the development process around open source development is fundamentally different to the development processes we use in our companies day in, day out. And so the same challenges around PR still exist with long-lived branches. If you have a long-lived PR, it's going to be a pain to merge it. It's going to be expensive to merge. It's going to take a long time to review. And so people still are going to like small, tightly defined PRs that allow you to merge that functionality in. Now, of course, Git allowed us to do some really interesting things with branches. And as we often do as technologists, we think, well, this is quite interesting. Let's build something really complicated on top of it. And then hence we enter Git Flow. So what Git Flow does is Git Flow is a standard way of working with branches and a set of tools on top of Git branches to make it easy to sort of codify this form of working with feature branches. This is a diagram, one of the simpler diagrams that explains how Git Flow works. I say explains how Git Flow works, and I say simple. This is sort of anything but. So you've got a master branch, a hotfix branch, a release branch, you have a developer branch, and then you have your feature branches, which is where you do most of your work. And there are all kinds of programs, command lines that you run to allow you to merge in features and push it through to the hotfix branch and sort of merge it over to the release branch, and you go back to the master branch, and then you disappear upside your own fundament, and then you go home and cry. It seems to me that Git Flow, actually, when you get down to it, is optimized around the development process where developers work by themselves for a long period of time in a feature and then merge that feature in. I don't actually mind too much if that's what you want to use for your open source projects. That mirrors the way those projects work. I don't know about you, but I don't like, in a software delivery team that works 9 till 5 together, the idea that somebody's going to go off by themselves and work for a long period of time on a feature by themselves before merging it in. I hear some people that use Git Flow says, but Sam, we have really short-lived branches. Our features only last for a day or two. And if your features only last for a day or two, I've got no idea why you need Git Flow. You don't need something that complicated if all you're going to do is do a little change in a branch and merge it back in. You don't need that sort of stuff. And so a number of the teams I've been working with that have been making use of Git Flow, what you tend to see is those feature branches, it's almost like those feature branches are living longer because the Git Flow stuff makes things a bit more painful to check in, and the Git Flow stuff is there to support these longer-lived branches, which is sort of enforcing and encouraging a pretty bad behavior. We come back to this idea, we want to check in frequently. I don't want people working by themselves on features that take weeks and weeks and months before merging them in. I want to ship my software quickly. And again, the open source world is not your day job. Your day job is different. I mentioned earlier that sometimes the toggles and the features things can become complicated to manage, especially when you've got systems that involve lots of services. And you can sort of jury-rig your own control mechanisms to allow you to flip toggles off and on. Recently, in the last couple of years, a number of companies, or actually 2 companies have emerged that are actually providing platforms to manage feature toggles. In fact, there's going to be a talk, and if I haven't already missed it, by the CEO of LaunchDarkly talking about how to use feature toggles. And so you Split.io and LaunchDarkly both give you sort of a SaaS-based products, SaaS-based way of managing your flags. And so they can do some fairly interesting things, like Split.io, for example, can even turn flags off and on for certain user cohorts, which can be a nice way of hiding features for beta users. They can even do geocode-based toggles as well. So you can do a rollout of a feature to a certain country group to try and test it out, sort of a way of implementing a canary effectively. I'm a little bit skeptical about these, not because I don't think they work, more that for these to work, you have to often rely on somebody's centrally managed platform, and they're often a very critical part in your execution path. If I can't find out the values of my toggles in production, what happens? And so you do have to understand the failure modes around these things. And there's some very, very good documentation on how these two tools work that you can learn from. But I would urge you, if you're interested in using these things to manage your toggles, that you look and understand the architecture and what happens if you can't talk to the centralized server. And also go see the LaunchDarkly talks. I'm sure it'll be very entertaining. More recently, things have been progressing. Some people, anyone here read this book, the DevOps Handbook? So time's passed. The DevOps movement has been around for a while now. It's maturing. We've been living with GitHub and the things it allows us to do. We have now version control tools very widely available. TFS gives us Git support and has for a number of years. So we have access to a very powerful version control tool that actually allows us to make use of branches, much more lighter weight branches than we first did back in 2004 and before that. So has the world really changed? Has it shifted? This book was written by a number of people, including Jez Humble, who wrote the Continuous Delivery book. And it was really them distilling down their knowledge. And if you know much about the DevOps movement, you'll probably know every single person who wrote this book. And it's harder to think of a more prestigious set of DevOps authors as this. But they make a statement in the book, and they reflect actually on this idea of trunk-based development. Trunk-based development is likely the most controversial practice discussed in this book. Given some of the conversations I've been having over the last 6 months, I certainly agree with that. However, the data from the Puppet Labs 2015 State of DevOps report is clear. Trunk-based development predicts higher throughput and better stability, and even higher job satisfaction and lower rates of burnout. So what's this report they're citing? How many people here have read the State of DevOps report? Anyone? The rest of you should. It's a short read. They were quoting the 2015 version. Now I should have recapped that. The 2017 version is available. This is a report they put out every year. And what it involves is a statistically rigorous survey of multiple software delivery projects. And what they're looking at are what practices are used by high-performing IT teams. And high-performing IT teams are, if you're a high-performing IT team based on your throughput, so how quickly your delivery, so cycle time, how frequently you ship software, your failure rate, and also a bunch of factors about things like employee satisfaction, looking much more at the human factors. And what Nicole, Jez, and Jin Kim have been doing with this study is trying to understand, rather than relying on our gut feel about, oh, this practice works for me, therefore it's universally applicable, actually trying to carry out a statistically valid survey to say, look, these practices are used by high-performing teams. High-performing teams are more likely to be using these practices. Therefore, these are the sorts of practices that might be good for you. There's a whole bunch of stuff out there about how the report's put together. This is a quote from the 2016 report. We found that having branches or forks with very short lifetimes of less than a day before being merged into trunk and having less than 3 active branches in total are important aspects of continuous delivery and all contribute to higher performance. So does merging code into trunk or master on a daily basis. Now, the report does not say that if you have longer lived feature branches that you can't be successful. Just that the vast majority of the high-performing teams that they see through this study over the last several years are using these sorts of techniques. They are merging in their branches very frequently. They're not letting them live for very long. And ideally, they're integrating into trunk on a daily basis. So, Sam, are you saying that all branches are evil? Not necessarily, no. For me, it's all about integration frequency. If you're using branches, but integrating very, very frequently, I think you're probably going to be fine. I think some people's value of frequently differ. I like integrating daily. Other people, maybe, every 2 days or something like that. That's kind of okay. The key thing to keep an eye on, if you are going to be making use of branches, and all the evidence we've seen so far, you really want to be making sure you're checking in frequently. If you're finding you're not able to integrate frequently because your code is taking longer to work on, maybe the feature's taking you more time, have a look and think, can I actually make this feature smaller? Can I break this work up into smaller chunks? Or can I use techniques like feature toggles or branch by abstraction to hide that half-checked-in code to reduce how long I'm keeping those branches around for? I also think that once you get to the point where you are having branches that are very shortly lived, maybe only living for a day or two, shifting to trunk-based development that drastically simplifies your use of your source control tools is something that's quite possible. So keeping your batch size small is going to keep the size of your branches small. Integrating often is going to reduce your merge pain and make it easier for you to ship software to your customers. And shipping often is going to reduce the pain of your release cycle. It's going to get software out to your customers more quickly. It's going to give you data on whether your software works. So really, in summary, has much changed since 2004? Yes, a load of stuff. And also no. It still feels to me like the same. And actually, it's not just a feel anymore. We now have good studies out there that back this idea up. Tools like GitHub are fantastic. The processes around things like pull requests are great when you have a mix of trusted and untrusted committers. And they can even work inside organizations where you have that mix of people. But most of us don't work in those environments. Most of us are working with a set of trusted colleagues on the same project, working a 9-to-5 day. And so I just question the value of some of these practices in those kinds of environments. Anyway, I hope this talk didn't make too many people angry. I'll be annoyed if it made no one angry, though. But anyway, thank you so much for your time.